Hi everybody, and welcome to Eniat, Washington and the Napeequa schist, the Napeequa amphibolite, the Napeequa quartzite, the Napeequa chert. You get the idea. This is a heterogeneous exotic terrain unit, and I'm starting to realize it's more important than I thought once upon a time. The same Napeequa that we saw up at the North Cascades Highway, but here we are down low, not far from the Columbia River. Thanks for joining us. We'll start with the Napeequa, probably get into some Entiat Pluton, and look at a bunch of maps and other reports. Thanks for joining us. Let's get started. So I think the best thing we should do is just kind of give you a sense of this outcrop, and then we'll go across the highway and read a little bit. So there's clearly some quartzite material here. Pretty significant beds of quartzite. Let's just stay with that for a second. Come over here. Would you believe I forgot my rock hammer? Of all days to forget my rock hammer. What the heck? Wake up. Okay, so some quartzite. I'll leave that for you. That'd be good enough, but then you'll see that we get out of the quartzite, we get into what I think is amphibolite. In other words, these are metamorphic rocks that have some bedding, they have some banding, they have some organization, at least at this outcrop. Let's get some better light for you. I don't know, we'll have to read over at the white car, but I think this is interbedded. Oh, look at this. Yeah. I think this is interbedded amphibolite and quartzite. And this dark look, well, I don't know, maybe it's not. Before I start reading with you, I'm thinking this is the old Pacific Ocean floor basalt, a mid-ocean ridge basalt that has then been obviously lifted out of the ocean. Temperature and pressure added to it. And now an amphibolite, and now an amphibolite. Rather sparkly, micaceous look. So there's some elements of schist in here. I'm confident that when we start reading that we're going to see that this is a real mixture. Not necessarily a melange. I wouldn't say, at least right here, it's chaotically mixed, but there's a number of rock types that are collectively called Napeequa. Pretty good looking quartz veins here on occasion. It's a lot of this schist that's quite impressive. All right, you getting an idea? Overall, I think we can say that at least right here, the Napeequa amphibolite, quartzite, chert, schist is bedded, is not a total chaotic mess. There's some organization, there's some bedding, there's some foliation, I suppose there's some lineation if you really get down to it. Not my strength. I'd say this is pretty representative of this Napeequa unit. Okay, well, let's head down to the car, look at a few maps. Try not to wipe out on this outcrop. Thank you. Okay, well, that was a little bit too busy and hot as well. So I've gotten myself up into a little side canyon. And there's different rock to discuss here, but before we get too carried away, let's get ourselves located here. Enjoying myself on a Labor Day. Hope everything's going well with you. So, getting ourselves oriented. This is a big loop you can take through the North Cascades. Here's Stevens Pass earlier this summer, Lake Wenatchee earlier this summer, Leavenworth earlier this summer, you get it. Wenatchee, and now today we are, I need help. How do you pronounce this properly? Are you a local? Entiat? Entiat? Eniat? Help me out, thanks. I'm doing this little side trip here, and I think I'm going to try to get up and over and drop into Lake Chelan and make a little loop, which I've never done. So I've only been up this Eniat River Road once before. That was 5 years ago with a field trip led by Chris Mattinson, the guy that I teach with here. But this is kind of the general layout today. So what's the geology in here, you say? So I've always liked this little map here, which is in the northeast quadrant map put out by the Washington Geological Survey. The German chocolate cake. Here's Dry Falls area, Grand Coulee, Ice Age floods, Joel Gombe Binary, you know, a bunch of different things we've been doing in the springtime. But now once we get out of this huge cow pie, German chocolate cake, more appetizing, we can realize that this exotic terrain nature of the North Cascades, as I mentioned in the last video, certainly extends underneath all this, but we'll never know exactly what the terrains look like underneath the cover. Okay, well, Wenatchee itself, Labor Day traffic on both sides of the Columbia River. And in the last video, you remember I mistakenly drove 6.3 miles up into the heart of the Squacain Gneiss. That's not today. Today, I'm up out of the Squacain Gneiss, and I'm into this stuff here. That was the Napeequa we just looked at our first part of this video. And then I am currently in this thing called the Entiat Pluton. So those are the two rock units today. And notice this heavy black line with some black triangles. That's a fault, and that's a traditional symbol for a thrust fault, where this stuff is thrust up and onto this stuff. But we're going to realize that Bob Miller is labeling this the Dinkelman décollement, or detachment fault, and more coming on that in a second. Here's the only other time that I was at that outcrop that we just looked at. Can we please get a little better sense of the Napeequa before we look at a few more maps? He asks himself. Well, here's Bob Miller and Friends, 2003. We have moved into the central part of the Napeequa complex, dominated by quartzite, metachert, silicious schist, say that 3 times fast, hornblende plus or minus biotite gneiss, less common amphibolite, ultramafic rock, marble, and rare pelitic layers. And those rocks are intruded by an orthogneiss body, and more than one, including up by the North Cascades Highway, for instance. And I've shared this with you before. Stacia and Bob and Kirsten Sauer were leading a field trip, sharing their most recent information. And there's a couple things that I really want to hammer now with the Napeequa. Come on, boy. The northern Napeequa, and that's what we looked at with Bob and Stacia directly in July, if you recall, is intruded by Skagit orthogneiss bodies, whereas the Napeequa to the south sits structurally on top of the Swakane gneiss on the Dinkelman-Dagholm. Okay, showed you this last time. I still really like it. Last video we were in the Swakane gneiss. That's this squirrely pattern. We're done with that for now. We just looked at an outcrop of Napeequa, and I have to say that I am now into some Eniat Pluton. But before we get to the Pluton, let's look at the Napeequa and what Stacia and Bob and Kirsten have to say here. The Napeequa schist is a heterogeneous, metamorphosed oceanic complex of amphibolite and quartzite, with subordinate biotite schist, metaperidotite, and marble. The basaltic protoliths of the Napeequa amphibolites mainly have mid-ocean ridge basalt and within-plate basalt affinities. So this is the old ocean floor that's now here in central Washington. Zircons from 3 amphibolites in the northwestern part of the Napeequa, up by the Skagit gneiss, have ages between 245 and 225 million years ago, likely indicating a mid-Triassic protolith age. So the ocean floor from the old Pacific during Pangea time is what we're looking at with today's Napeequa. One of the amphibolites is Migmatite and has a small population of 76 million-year-old zircons. Well, this is where I lose it. I mean, I'm fine with a very old ocean floor. I can visualize that. And I can visualize it being now squeezed up in here. That's what this is, this old Pacific Ocean floor, the Napeequa, which comes right down to US 97A and 97, just a thin strip of it. This is the Columbia River, remember? But it's this action in the mid-70s which still confuses me. Well, this is my color choice. Swakane. I'm sticking with apple green for the Napeequa. So there's the Napeequa, there's the Napeequa surrounding the 10-peak Pluton. But I don't know if I'll stick with this color scheme, but the three generations of magmatic flare-ups in the North Cascades, the oldest flare-up back in the 90s, 90 million year old, 90s is the red, this very mysterious mid-70s flare-up in orange, and then the Eocene flare-ups in purple. So here's the golden horn batholith, for instance. We'll see if that works for you. Here's Hildebrand. Different color scheme. I don't know, I kind of like it because it shows the Napeequa. The Napeequa, you can kind of see now, this dark brown is, the Napeequa was here first. Now, I don't know where we are on planet Earth when we invade the chocolate brown Napeequa from below. Are we down in Mexico? Are we in California? Are we, God knows, are we out in the ocean somewhere? I don't know. But I like that consistent look of that Napeequa as kind of the background, and then here's all this invasion of plutons from below. But this is the one I'm really shooting for here. Colors are wrong for us, but by now we have a good sense of this. I've been making videos with you this summer, and by now we have looked at the Suaqueine gneiss, the Napeequa, that's what we're looking at today, the Chewocum, and the Ingalls. That's what we started with on July 1st, if I do believe. So the colors are wrong for us, but this is just a generalized cross-section of the relationship between these four exotic terrains. Suaqueine at the bottom, Napeequa, Chewocum, and Ingalls. Now, what does your eye notice? First of all, what are these? Hearts and arteries and valves and stuff? Livers and kidneys? Well, I guess it kind of looks like that, but you know what those are. Those are plutons of different ages. And the granitic rock is called tonalite in this case. That's a very specific kind of granite, but let's just call it granite. Look at how much invasion of plutonic material, how much magma has been pumped into both the Napeequa and the Chewocum. At depth, I might add. But look at the Suaqueine. Not one pluton is coming up through that stuff. Why? And see, the structural boundary between the Suaqueine and the Napeequa is this Dinkelman fault. So Dinkelman Canyon is right around the corner there. Dinkelman Canyon, Dinkelman Ridge. Whoever Dinkelman was has his name all over this stuff, and Bob Miller took that name Dinkelman and assigned it to this detachment fault, or this décollement. So the idea is, and I still am a little bit fuzzy. Well, let me finish my thought first of all. Here's the Windy Pass Thrust, WPT, and you recall that's the boundary between the Ingalls thrust up on top of the Chewocum. That was established a couple months ago with us, right? And that's the Mount Stewart Pluton invading from below. Well, there's no Pluton crossing the Dinkelman, and apparently, I'm fuzzy though, apparently the Dinkelman fault has two different kinds of movement on it, depending on what vintage we're talking about. If we're back in the early days, let's say in the 90s, 90 million years ago-ish, the thing was a thrust fault. And the Napeequa, well, I don't even know that. I'm not sure that's right. I'm getting tongue-tied just as I talk to you because I realize that the Suaqueine is young. Okay, so I think all I'm prepared to say is that there has been detachment fault movement. In other words, normal fault movement of the Napeequa sliding away from the Suaqueine, and the Suaqueine being exposed as a result. But even as I say that, I'm a little confused. Can I find a good map? I guess all I'm trying to say is that to look at, yeah, they don't even have the fault on that. Didn't have another map. Yeah. So here's yet another map. This is the Chelan quadrangle. Colors are wrong for us. Suaqueine, Napeequa in two different shades of brown. The Dinkelman is shown as a thrust fault on this map, and yet it's talked about as a detachment fault. Is that the same thing now, or I got to work on that? You see Dinkelman Canyon, Dinkelman Ridge. So our first stop was here at the Napeequa, and now I have stopped along the side of this quieter road right here, going up Mud Creek Road. And if all goes well, I don't know what the road is like. Now I feel like Norley. Whatever the road's like, I don't know if it's paved, if it's tarmac, or if it's dirt. And find some petrol. She's got all her phrases. I'm going to follow, I know I'm in the Eniat Pluton right now, and I'm going to continue up Mud Creek Road I think it's going to go up and over and drop down to Lake Chelan. And if so, then I can get into some of this darker gray, which is the Chelan Migmatite. All right, well, that's the plan. So, let's go look at some Eniat Pluton, shall we? Do you have the keys? I have the keys. Okay, well, pleasant in the shade. Let's go to, this whole thing is Entiat Pluton. It's a big Pluton. I think we'll do one more thing once we get back to the car. Talk about some new dates that we have on the Eniat. So this is technically a tonalite, but I think it's going to look quite similar to a granite for you, just generally. Oh, it's kind of handsome, isn't it? Those are big crystals. These are pretty big crystals for this material. And surprising amount of black material. Those look like hornblends to me, those black shiny things. And as I rotate them, you can see the light reflecting off. That's a cleavage surface on each of those hornblende crystals within this Eniat tonalite, aka granitoid material. Now I could spend the next 4 hours going up and over, but I don't know if I need to. It's all right here. Big Pluton. Yeah. Yeah, those are beautiful hornblends. Wow. Look at that. Let me zoom on that. Wind's picking up. I'm going to keep this one. This is nice. It's beautiful. All right. And the more weathered look is less intoxicating, I suppose. But, you know, as you look at these cliffs, I'm going to just continue to drive. I want you to remember that this kind of big, beautiful, ferric, phaneritic textured tonalite is the look for the Eniat Pluton. So, on the maps from 60, 70 years ago, the Eniat Pluton was quite large and quite long and skinny. But Jenny Matzell did some work on the Eniat Pluton, and probably many others as well, but she contributed to the fact that, I think I've got this right, that the Eniat Pluton is not one big Pluton anymore, but it's been split into two Plutons because there's distinctly different age and chemistry material. This is all in the shade, but will this give you a nice look as well? Yeah, I'm very impressed with this Eniat Pluton. Should I say that it's more impressive than Mount? It's not a competition, but wow. Finger in there for scale. God, those are gorgeous hornblends. Can't get enough of those. Let's get old Hildebrand's map. And I guess we'll read a little bit more. So if I get an older, can I get an older map first? Oh, why bother? Let's just give you the most recent version. So once upon a time, this whole thing here was called the Entiat Pluton. But Jenny Matzel, 20 years ago, sampled in here and realized everything was 91 million years old. Now that's a familiar number to us, right? That's the major flare-up to make the, what did they call it? This is the hook and the stem and the mushroom, to make up the mushroom of the Mount Stewart Pluton. And so a new name was given. I think this is a relatively new name. Seven-fingered Jack Pluton is this portion of the formerly finger-like Eniat Pluton. So now on maps, the Eniat Pluton is half of the finger. It's like, you know, basically cut it off at the knuckle, because this stuff is 20 million years younger. And we're into this mysterious, enigmatic series of plutons and other series of truly bizarre activity, as far as I can tell, in the North Cascades in the 70s. In the 70s. Yeah, so this is, I don't know who made this sketch originally, but they were calling all of this the Eniat. And now with my color scheme, I'm taking this portion, which is now the seven-fingered Jack, red, and just this being the Eniat. They're still quite long and thin, right? Kind of surprising. Eniat Pluton. All right, let's finish off reading here a little bit. 2003, here's Bob Miller. Relatively homogeneous and wide southern end of the highly elongate 72 to 73 million year old Eniat Pluton. Dominant biotite hornblende tonalite. Microgranitoid enclaves, Chelan layers, and local diffuse contacts reflecting the important role of mixing and mingling in the evolution of this Pluton, which crystallized at relatively low pressures, 6 kilobars. Well, that was quite an adventure. I don't know how I got onto the roads I did, but I managed to cross up and over to Lake Chelan area, and down below is Navar Coulee, which I certainly know from an Ice Age perspective, but I'm not thinking about the Ice Age for sure now, and not until next spring. And we're back to a decent dirt road, but man, dusty, thick sediment, thick dirt. Didn't have the proper map, so I wasn't sure where I was for half of it. But anyway, I'll show you on my map what I was working with and how I managed to get to that. It was beautiful country up high north of the Eniat River and before dropping down to Lake Chelan, as I've done now. And I don't think I'll bother to get a shot of the lake for you necessarily, but not a whole lot of outcrop to work with. But finally, after kind of working my way down low, heading towards the lake, we have some Chelan Migmatite. So I've crossed into another exotic terrain, and it may not look a whole lot different to you. And I don't know. I guess I stopped because kind of this stuff caught my eye. So I haven't done my homework now. I don't remember the details of the Chelan Migmatite and what I was able to learn 5 years ago with Chris Mattinson, who has spent considerable amount of time, and his father before him, Jim Mattinson, on the Chelan Migmatite, and Cliff Hobson, and so on. But what I can relate to you without doing my homework is that this is a far older story. We're older than 100 million years ago for some of the original Pluton making factory action with this Chelan Migmatite. And I think the group that I'm working with, Bob Miller, Stacia Gordon, Mike Eddy, I don't think they're dealing with the Chelan much at all. As far as I can tell, most people aren't really dealing with the Chelan Migmatite much. That's just my impression. I could be totally wrong. But in part because it's maybe extra complicated. Not sure. Look at that. But a migmatite, as I've tried to describe it to a general audience in past episodes, is kind of a swirl of igneous and metamorphic activity. And what we're looking at is what it looks like in deep levels of the continental crust, kind of underneath where a Pluton is being created. So I came up with the phrase Pluton factory. I don't know if I want to keep with that, but yeah, this is a handsome outcrop in the heat of the day. Yeah, I think I need to go up there. So, I'm going to stop this episode here. And I don't know, maybe I'll come back up in the next video and look a little more carefully at this Chelan as I work my way north. But now we're getting far enough away from... yeah, that's nice too. This light. Maybe the wrong light for you, but... we're getting far enough north now where I just can't easily just bust back home for supper time with Liz and Bijou, but yeah, maybe I need to put this on my list and do an overnight up here. I mean, it is Labor Day. I'm going to have to put my white clothes away, ha ha ha. But it is a great time of the year to be out. The weather's still great. Most of the people are back to their normal lives. And that means places like this, which are not overrun with people anyway, necessarily, are really not overrun with people once you get to mid-September, late September. So I've got a couple weeks before school starts. Yeah, I might come back up here, do a little bit more. And you're like, oh, come on, that road doesn't look bad. Well, you're right. This is great compared to what I was on half an hour ago. I was in deep sand and all sorts of stuff. I guess I hit a wrong turn, but anyway, made it out the other side. Oh yeah, this is... So I'll have to be extra careful to give you a GPS location for this outcrop because I'm not exactly sure where I am, except I'm confident that's Navar Coulee down below. I can't even remember if there's a main road going through the floor of Navar Coulee, but it's starting to get late in the day. I need to get back home. Extra crazy swirling action within the Chelan Migmatite complex. Daunting, even for the North Cascades. And all the complications that exist in the North Cascades, even for that. This is intimidating, I think is the way to say it. But I'll do what I can. And of course, part of the thought always is, how much am I going to use this winter? I mean, I'm continuing, okay, I'm just workshopping with you here. I guess in session A or session B this November, when I start the Baja BC A to Z live stream series, I will set some of the goals for the series. And maybe I'm starting with the North Cascades. Maybe just a couple letters worth of review of what I've learned over the last couple of years. Yeah, maybe this will work. And then try to keep broadening out, broaden out, until finally we're talking about a vigorous discussion about key evidence for major amounts of northward migration of some of that crust. That, yes, is in the North Cascades today, but if I just tackle Baja, BC without any sort of payoff, without any sort of structure, maybe that's not the way to go about this. So maybe I do keep circling back. Oh, I can't get enough of that one right there. Maybe I do keep circling back. Yeah. As I was doing last summer, if you recall. I mean, isn't that right? Isn't last winter the crazy Eocene A to Z? I mean, we were in Wyoming. We were in Idaho and Montana. But I kept saying I don't want to go crazy on this unless there's some sort of payoff to better understand the North Cascades of Washington. Yeah, I think that's what we'll do here too. Okay, so this was the map I was following, so terrible scale. Oh, by the way, I meant to show you something. This is wild. I stumbled onto this by accident last fall, I think it was. You know, well, first of all, let's get your bearings. So here's Lake Chelan, which in itself is so crazy. In other words, it just sticks out like a sore thumb. Why is this lake so long? Why is this lake there? That's an Ice Age discussion. Here's the Columbia from the town of Chelan, the Columbia River flowing south to Eniat, flowing south to Wenatchee. So that's how I will drive home in just a bit. But look at this. So this is the German chocolate cake, which extends all the way that way to Idaho. Brown, right? German chocolate cake. 3 miles thick in the middle, less than a half a mile thick at the edges. Look at this. Up there high in the Spokane. Wow. Really? Somebody else on this road? Up there high in the Spokane is some of the German chocolate cake. And there's an even bigger piece of it here called Dick Mesa. Yeah, where'd you go today, honey? Oh, I went up on Dick Mesa. I beg your pardon? So Dick Mesa, up above Entiat, Washington, up above Earthquake Point, which I think is right there, is a little scrap, and here's another little scrap, and here's another little scrap of German chocolate cake. In other words, of flood basalt that used to, for sure, cover most of this exotic terrain material. I mean, you can say that pretty easily with these scraps. To my knowledge, there are no more scraps further to the west. But it is an interesting question. How much further, how much more lava was there 16 million years ago? And why is it gone now? Well, there's been plenty of uplift and ice age flood erosion and everything else. So that's kind of a cute little wrinkle. Well, here's what I did since I talked to you last. Actually, let's do this whole video, which I'm wrapping up now. Started the video here, Napeequa. Continue up the Eniat River. Hang a right just past Ardenvoire. Might need help with that as well. A little old cafe and general store right there. Hang a right on Mud Creek Road, and I stopped pretty quickly, and I'll give you a GPS location for the Entiat Pluton on both sides with those beautiful big hornblends, you recall? Well, as I continued up, as I continued up what looked like pretty major road, it turned to dirt pretty quick. So the pavement left, pretty dirt. Turned dirt pretty quick. Continue up, dirt gets more and more wimpy. And then up towards the summit here, somehow I lost the main dirt road. and I was up on some stuff that I shouldn't have been in. Thick sand, essentially. So Whitey got me out of there, but there were a couple moments I'm like, wow, okay, I might get stuck here. I mean, it's just as dry as can be, but that thick sand, I think you know, once you get in that and you start spinning, you're tough to get out. Finally, this whole area here is the Chelan Migmatite, this purple with the kind of, I guess just this purple. So Entiat Pluton is left. There was a sharp contact, couldn't see it, not much outcrop. And now I'm about to drop into Navarre. I think there's a road, isn't there? Isn't there a road that comes down Navarre and then hooks me back up? Yeah, at the Great Terrace. Ha ha! That's right. So Lake Chelan's nearby, and maybe, not sure, but maybe the next video will be looking a little bit more at the Chelan and then continuing north and getting into, God, is that the Cooper Mountain? I think it is. Cooper Mountain Batholith. Oh, we really are getting up into Dream Team country in the Foggy Dew area. Okay, let me flip you around to say goodbye. Well, thanks everybody for watching this one. Continuing to learn as I struggle mentally, as I struggle physically, getting around out here. But there's so much to learn, and it's just great to have you along as we piece some of this stuff together. And occasionally I get tips from you all with your comments that you leave about a paper, or maybe just some general reaction from you that helps kind of steer me in a particular direction. And so I say, from Lake Chelan area, thank you, I love you, and goodbye.